Good afternoon, everyone. Happy Friday. My name is Rafael Talavera, an ingoing second year at the University of California, Santa Cruz, currently pursuing my bachelor's in bioinformatics, a summer trainee at the project known as Phenotype Discover for dbGaP, or PhD for short. My mentors during this time have been Dr. Ono Machado, Dr. Duan, and Dr. Yildiz. And my purpose for being here today is to present the data sharing problem that our project is addressing, our plan of approach, and the progress that we have made thus far. I'd first like to begin, though, with what dbGaP is, which is an online repository of over 300 studies which focus on seeking relationships between genotype and phenotype data. And so what our project is responsible for doing is standardizing the study name, its description, and the phenotype-related data. And so what we first sought to do was to determine what kind of limitations the current system has in place. And so in this example, I'm showing a screenshot of a free text search which returned 10 studies, first 5 of which I'm calling false positives, and the 6th of which is the target study which I was actually looking for. And so what we try to take out of this is that many searches have problems like these, where the list might be in incorrect order, where the studies that are actually retrieved might be incorrect altogether. And the simple searches also, the free text searches also have to be limited to 2 to 3 key terms. The dbGaP system in place now also offers an advanced search option, a number of 35 field names, each of them with an index. I've chose this to show you this index to show you how many of those indexes are coded, making them or limiting their effectiveness and the usability. And so keeping these limitations in mind, our goal at the project is to develop the methodologies and a tool that would support the easiest navigation of our database. The approach that we propose to do so is to first use semantics on phenotype variable descriptions to label key information. Let me get myself acclimated real quick. Oh yeah, and then semantics makes it easier for the natural language processing techniques to extract key information from free text. And the last piece of the puzzle is text mining techniques, which supports the information retrieval system. And for the visual learners, I provided this diagram. We at the project began with the existing data and submitted studies in order to kickstart our system, in the hopes that a biomedical researcher might be able to use free text searches to retrieve the information they're looking for. And so the next couple slides will go into the tasks that went into the development process of parts of the system, namely the semantic annotation process and the information retrieval process. So first, we took a subset of 2,000 variables which pertain to pulmonary studies. We then had a number of things that I had to look for, such as a theme, a target of information, an event, and a linkage, which would then support the next step, which is information modeling. And we found that 93% of those 2,000 variables could fit into this model. And so we're currently trying to expand the model into other variables. An example of an information model, and I've highlighted the key points that I just annotated in the descriptions. So the theme, the target of information, the event, and their linkages between those key points of information to describe relationships. So the next step for that process was to develop information models like these for non-demographic related variables. The last 2 tasks that I've been currently participating in went into the evaluation and the development of our own information retrieval system. And so in the first, we investigated how well the current dbGaP system can rank relevant studies. And so in this example, I provided I attempted a keyword search using cardiovascular men and was returned Women's Health Initiative. And so what we took out of that is that the current dbGaP search tool might be looking in parts of the study's body that are not necessarily indicative of what the study's focus actually was. Also, in this example, it'll show you how it mapped a match between women and men. And so this is currently going into our development of a ranking algorithm. The last task that you see there is to develop a percent accuracy or a percent precision, if you like, to then use as a standard for our own search tool. And so I was given a list of 8 use cases. Use cases I mean by questions that a biomedical researcher might be asking themselves. I simplified those and returned a number of studies. We determined that the current dbGaP tool has a roughly 50% precision rate. And so we're trying to build on top of that, and I hope that our system would be better than 50%. Using that information that we have been investigating of the current dbGaP system, we developed 2 tools, first of which is known as Diver, which served as the back end of our system. And what Diver does is it annotates free text descriptions like you see there, and annotates them for the key information. This back-end system then supports the information modeling process. There's also, this is one of our tools that is currently under review. The second tool that are currently developing is the front end of our system, or the information retrieval system. And what this one does is to take free text input, retrieve relevant studies, and then use a ranking algorithm to rank them in a proper order that I hope that our tool is, and I'm pretty confident that our tool is better than 50%. And to quickly summarize, PhD, our project has been building upon the existing system that is in place now, and has been developing as a more reliable, flexible, and shareable system with which to navigate the database. There's still many things to do, a few of which I've listed there, which are still to standardize non-demographic related variables, to develop ranking algorithms, and the last point there is to give you an idea of how much information we have to analyze and process. At the bottom left, I provided for your interest the website for our project, where you can learn more about us and what we do. And the bottom 2 are for the 2 tools that I've just described. And so with the remaining time, I'd like to thank the research and development team, the co-principal investigators, and our supporters at Cal IT2, I-DBMI, and NIH. Personally, as a bioinformatics major, this has been a unique learning process in that I've been able to get an understanding of the challenges facing the field and the pieces of the puzzle that go into addressing those challenges. I'd just like to say really quickly about the field itself is it costs a lot of time and investment from these people and our supporters, but the repayment from being able to answer old questions about diseases and other disorders will be repaid, and we will be able to ask other questions in the future. And with that being said, thank you for your attention. Any questions? Take this up.
Oh, okay.
I was going to say.
Actually, I was just curious if you think it'd be possible to implement some sort of feedback loop into the system so that maybe users could give you some sort of input about whether or not those search queries are actually bringing back relevant hits, or if they're completely irrelevant.
Not so fast, Rafael.
So I heard that you thought about implementing a feedback loop,
Yeah.
which would then...
Well,
sorry, I missed the last
if
part.
you're returning a large amount of hits in a query that are completely irrelevant, maybe the user could give you some sort of feedback, and that could help rank them.
Yeah, definitely.
future.
That's something I don't think our team has been considering, but I think we could in the future.